two. Okay, it's probably okay now. All right, so this is lesson 4, group meeting quiz. Are you ready?
Oh yeah, I'm ready.
Okay. It says we have to give everything as decimals, so. All right, the information for the first one is human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Okay, so you can see the table. So the blood types and the proportions, question 3, the blood types and the proportions given in the table above define a probability distribution. So they add up to 1, so that would be true, right?
Yep.
Okay, so moving along. What is the probability that a randomly selected person in the United States has type O blood? So according to that table, looks like 0.45. Do you agree?
Yep.
Okay.
I agree.
And then what is the probability that a randomly selected person will not have type O blood? What do you think?
Let me, I'm trying to get my calculator going here. So would we just do the combination of the others and?
Well, the easiest way is it's either going to be type O or something else, right? Yep. So if it's either going to be type O or something else, the easiest thing would be, instead of adding the other ones up, would just be to subtract type O from 1. Although I bet if you add them up, they would get, you'd get the same thing. I'm going to split back up the table here just a second. Yeah, you get the same thing whether you add them up or whether you subtract 0.45 from 1. So what do you think that gives us?
The 0.55 or?
Yeah, that's what I think too. So we should save that one. Moving on, your turn to read the question.
Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle 1 of the dogs demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a patient identified as a bladder cancer patient. If the dogs guess at random what's the probability they will correctly identify the dish containing the specimen with the bladder cancer patient?
So that's 1/6, which rounded to 3 decimal places is what? .166666. So 0.167, would you say?
Yeah.
Okay.
I agree.
All right, next one. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer, or there is little evidence that dogs can detect bladder cancer. Which one do you think?
I think the strong evidence.
Me too. Hopefully we get this right. Okay. Moving on. Little old M&Ms. So now I have some M&Ms in my house, and I'm semi-tempted to go count this, or just to go check. But anyway, just because it'd be fun to know. So M&Ms are small chocolate candies. The M&Ms website previously indicated that in the U.S., the distribution of the colors in a bag of plain M&Ms is given in the following table. And they don't have the one for green, but they should all add up to 1, so green should end up being, let's see, about, well, all of the rest add up to 0.84, so green should be 0.16. Is that what you got, or what you get when you do it?
Mm-hmm.
Okay. So if you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? What do you think?
Oh my gosh, I don't know.
Look at the little talent table.
I would say one. Well, would we go with the 1-3 or?
Yeah. That's because that's how many proportionally there are. So that's the chances that we would get a red one is 0.13. Then what's the probability that a randomly selected candy is green? Well, we just calculated that 0.16 is the proportion of green one, or 0.16 is the proportion of green ones. So that should be it, right?
Yep.
Okay. And then what is the probability that a randomly selected candy is not green? So we can either add up all of the other ones or we can subtract, but we had to add up all the other ones to figure out the green one anyway. So
would it be the 0.84?
I think so. Okay. Here's the part I hate. This is a review of last time. I'm still feeling uncomfortable with last time. Anyway, the ACT scores of students admitted to a medium-sized public university in the Western U.S. were taken from capex.com. The following summary statistics were calculated, so I guess we just use this chart. Half of the observations are less than or equal to what number? So half is the median, right?
Mm-hmm.
So that'd be 24.
24.
Yeah. 24, okay. I had this long discussion with my husband about mean, median, and average and central tendency the other night. And I think I feel better. Okay. Okay. Based on the top information on the table above, the top 25% of the students scored above what number? So that'd be the quartile, the
one.
third quartile. So what?
Oh, is it the? Okay, I thought it was quartile 1, but I just could not figure out.
Quartile 1's the lowest one.
Okay,
so
all right.
Quartile 1's the lowest, and quartile 3 is the highest.
Yeah, that's why I couldn't figure out the box plot.
So yeah, so 27 is what they say quartile 3 is.
Grandma, that's you.
So that's okay. And you can kind of tell that because if you look at the chart at, quartile 3, the score is 27. At quartile 1, the score is 22. So that tells you that the bigger the quartile number, the larger the descriptive statistic number is.
Mm-hmm.
But also,
so would we go with 27, or are we doing it out of 100?
Yeah, we go with 27 on that because that's the third quartile. They scored at least 27, but higher actually. And we won't go with maximum because we don't actually know, how many there are or anything like that. Yeah. So, and 35 is just happens to be the maximum you can get on the ACT test, as it turns out. And we've got the interquartile range, but since we don't know what that is, it doesn't, I don't know. Like I said, it was helpful to talk to my husband about measures of central tendency. That helped a little, but I'm going to have to make him go through it with me again. My daughter just informed me she knows what it means, but right now I don't care. It's not important. Later, you can tell me in a few minutes. Okay, so
I speak English, not math.
Okay, so then the next question is question 13. Which of the following statements is not one of the 3 rules of probability? So the probability that an outcome will not occur is 1 minus the probability that it will occur. Well, that's true. That's one of the 3 rules. A probability is a number between 0 and 1. That's one of the rules. If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. That's not one of the rules.
Yep.
So that'd be the one that's not, because the other one's true too. The sum of probabilities in any. So I think that's true. So I think, go ahead.
How did you do on the homework quiz when you took it?
I haven't finished taking it yet for the other one.
Oh my gosh, I totally bombed that.
Well, you get 2 attempts, so I was working on it. I've got to finish working on it. I've got to work on it. You get 2 hours, and I interrupted students.
Don't submit yours yet, because I just submitted mine, and question 6 is wrong.
Okay, well, let's look at question 6 again. Okay, what's the problem? If the dog guesses at random, what is the probability that they will correctly identify the dish containing the specimen? Oh, wait. Oh, there's 7 bowls. It's 1 out of 7. That's why. 1 out of 7. So 1 out of 7 is, you can attempt this twice. You knew that, right?
Yeah, yeah.
Okay, so 7 goes into 10.
So I got the,
Okay. So 7 goes into that once. 10 is 30. It goes into that 4 times. Goes into 22 times. Goes
I
into
got 1.4.
1.4. How many decimal places are we supposed to go? Let's see. 3 decimal places. So 1.43, 0.143.
Yep.
Okay, so then we have to go back then. Ah! I'm trying to take the quiz on my phone. So it's
Yeah, I'm on Hangouts on my phone, but I'm on my computer for the quiz.
yeah, I do it just backwards because
I couldn't find my webcam in the fast pace this morning.
well, I can't see your smiley face too much either on this. It's just giving your voice. So, okay, so all right, so the rest of it should be fine, right?
Yep, the rest of it's fine.
Well, it's nice of you to be brave and submit it. Yeah, that's my fault. I didn't look at the total number of bowls correctly. That's one of the problems I have is I have to really pay attention to that because sometimes I understand the process, but I don't pay attention to the number as well as I ought to.
Well, you're doing better than me because I'm still struggling with the process.
Well, it depends on what the process is. Last week, or the last one that we did was really hard. I personally thought the last one was really hard.
Yeah.
Okay, so in order to stay on track, then we need again on Monday to do the one that's due on Thursday of next week. Can you do that? Does that work for you?
Should be fine. I would just have to do it because I normally don't get off at 5, and then I have to pick the little one up at daycare before 6. So I could do
Okay, so when
while I was at work.
What mountain time works for you?
If you want to do like 6 Mountain Time, that'll be right at 5 for me, and I can do a quick meeting while I'm at work and then pick.
But does that give you time to pick up your daughter?
Yeah, because she's like 5 minutes away.
So if we do 6 Mountain Time, that works?
Yeah, that should be good.
Okay, because that also works for Ashlyn.
Yeah, that'll work.
Okay. All right, so 6 Mountain Time, I will submit this tape, this link, and I will remind Ashlyn that we met this morning, and also, I mean, she should know because she got a couple of emails and texts, but also remind her that it's Monday at 6 Mountain.
Okay.
And good luck with the rest of the homework.
Well, thank you. Sorry I was late.
It's okay. These things happen. I just worked on the rest of it while you were doing it. Okay.
Oh, yeah.
All right. Talk to you Monday. Have a good weekend.
You too.
Enjoy
Bye-bye.
Women's Conference tonight.
Oh, yeah, you too.
Bye.
Bye-bye.